Hello, my name is Nia America. Today I'm going to talk about TCP/IP model. This is TCP/IP model. We have application, concept layer, we have transport layer, network layer, and network interface layer. So as I reference model, we have one of this. They are pretty similar, uh, but interchangeable. The same concept, um, but different execution. First of all, what is TCP/IP model? TCP/IP model help determine how specific computer connect via internet and how to transmit data between them. It help create a virtual network when multiple computer network need to connect it together. TCP/IP stand for Transmission Control Protocol or Internet Protocol. It is specifically designed as a model to offer highly reliable and end-to-end byte stream over an unreliable internet. First of all, we're gonna go for layer 4, application layer. Application layer is the topmost layer down here. Used to handle all process-to-process communication function that provide the interface and protocol needed by the user to process communication across an internet protocol and IP computer network. It combines the functionality of a section layer, presentation layer, and the application layer of OSI model. Depend on the transport layer protocol to establish host-to-host data connect, data transfer channel, and manage the data exchange in a client server or peer-to-peer network models. Application layer does not describe the specific rule or data format the application must consider when communicating. This is the job for other layers, mainly the network access layers. Um, Other than that, they're also responsible for handling high-level protocol, issues of representation, and this layer also allow the user to interact with the application. When one application layer protocol want to communicate with another application layer, it forwards its data to the transport layer. So it send data to the transport layer. It facilitates the user to use the service of the network. It used to develop network-based application. It provides user service like user log, naming network device, formatting messages, and email transfer and sending. Um, Basically, application layer is where the user would interact with the data itself. So, like email or video and thing, it's like that. Uh, it also concerned with error handling and recovery of message. This layer uses numbers of protocol. The main the mains some are which follow HTTP, Hypertext Transfer Protocol. This protocol is for World Wide Web. It defines how hypermedia messages are formatted and transmitted. FTP stands for File Transfer Protocol. It is a client service-based protocol for transfer of file between clients and service over the network. SMTP, Simple Mail Transfer Protocol. This one is for laying rules and schematic for sending and receiving electronic mail. DNS, domain name system. This is a naming system for device in network. It provides service for translating domain name to IP address. Telnet is provide bi-directly net-oriented services for remote logging into the host over network. Simple Network Management Protocol (SNMP) is for managing, monitoring the network, and for organizing info about the network devices. Next, layer 3, or the transport layer. Transport layer is the third layer of the fourth layer TCP model. The position for the layer is between application and the internet layer. The purpose for the transport layer is to permit device on the source and destination host to carry on a conversation. Define the level define define the level of service used when define the level of service and status of the connection used when the layer transporting data. Define quantity of service. This means this layer will determine if the quality of service of that data will need to be high or low. So for example, um, maybe like an email or something, the quality of service will be low. It's because it's not really a priority. So the quantity of service will probably quite low compared to something like maybe a call or a live stream, something that must be accurate and have a high quality of service for it to work properly. So that's that. Uh, Function include message segmenting, acknowledgement, traffic control, section multiplexing, error detection and correction. This is resent and message reordering. It is responsible for error-free end-to-end delivery of data from the source host to the destination host. It corresponds to the transport layer of OSI model. The main protocol included in the transport layer are TCP, stands for Transmission Control Protocol, and UDP, User Datagram Protocol. Transmission Control Protocol is a reliable connection-oriented protocol that transmits data from source to destination without any error. A connection is first established between peers prior to the transmission. The sending host (TCP) divides an incoming byte stream into segments and assigns a separate sequence number to each segment. After receiving host, TCP reorder the segment and send an acknowledgement to the sender for correct receipt of segment. TCP also manages flow control so that a faster sender does not overwhelm a slow sender. This we'll talk about later. Uh, Next, user data protocol. It is a message-oriented protocol that provides simple, unreliable, connectionless acknowledge service. It is suitable for application that does not require TCP secrecy, error control, or flow control. It is used for transmitting small amount of data where the speed of delivery is more important than the accuracy of delivery. Same with um, like a video stream. Stream control protocol, stream control transmission protocol (SCTP). It combines the feature of both TCP and UDP. It is a message-oriented like UDP, which provides the reliable connection-oriented service like TCP. It is used for telephone over internet, one of those phones that are wireless and connected to the internet, usually in the office. Transport layer services are conveyed to an application via a programming interface to the transport layer protocol. These services include connection-oriented communication. It is normally easier for an application to interpret a connection as data stream rather than having to deal with the underlying dimensionless model, such as datagram model of the user data protocol and the internet protocol. This means same on the delivery. The network layer doesn't generally guarantee the packet data will arrive in time or even the same order they sent. Uh, this often is a desirable feature because this meant that use, through the using of segment numbering, um, the receiving passages to the application in order because uh, this will um, avoid head-to-line blocking, which occur when a single queue of data packet or the header uh, cannot move forward to the connection, even if other behind it could. So this is actually a good thing. Reliable. Packet may be lost during or prior to network congestion and error. Reliability. Packet may lose during transport due to network congestion or error by means of error detection codes such as checksum and transport protocol that we check the data if it is corrupted or not, and if we verify the data correct receipt by sending ACK and ACK message to the sender. So we will notify the sender if the message are corrupted or not, so they will reset it or not. So the automated repeat request scheme that may be used to retransmitted loss and transport layer. Retransmit lost or corrupted data. Flow control is the control of rate of data transmitted between two nodes that sometimes be managed to prevent a fast sender from transmitting more data than can be supported by the receiving data buffer, which will cause buffer overrun and can also be used to improve efficiency by reducing buffer underrun. Congestional avoidance. Congestional avoidance can control traffic enter from telecom network so as to avoid congestion collapse by attempting to avoid oversubscription over any other process or link capabilities of the intermediate nodes and the network they are taking resource reducing steps such as reducing the rate of sending packets. Uh, for example, automation repeat requests for the inner caching state. This can be avoided by adding conditional avoidance to the flow control. So it will include slow start that we keep the bandwidth consumption at a low level at the beginning of the transmission or after the packet retransmission. Multiplexing port can provide multiple endpoints on a single node. For example, The name of the postal addressing is kind of multiplexing, disguises between different reception of the same location. Computer application will each listen for information on their own port, which enable the use of more than one network service at a time. It is part of the transport layer in TCP/IP model, but the second layer is in the OSI model. Next, the Internet layer. Internet layer is the second layer of the four-layer TCP/IP model, transport and the network access layer. Internet layer pack data into IP datagram, which contains source and destination logical address or IP address, basically MAC address, and this information is used toward the datagram between hosts and across the network. The Internet layer is also responsible for routing of IP datagram. They also use checksum to protect the head of each datagram. So in each header here, we will have a checksum. We ensure the information received is accurate. The Internet layer allows hosts to insert packets into network and have them delivered to the destination on the same network or another remote network. On the destination site, data packet may appear in a different order than they were sent. It is the job of higher level to rearrange them in order to deliver them to proper network application in or at the application layer. So what it's saying here is that Internet layer is responsible for logical transmission of data packets over the internet. It can be compared to like the network layer, OSI model. The main function of the layer is transmit data packets to loop layer. For outgoing packets, select the next host gateway and transmit the packets to the host by passing it to the appropriate layer implementation. It routes each of the data packets independently from the source to the destination using the optimal route. Capture packet and pass the packet to the appropriate transport layer protocol if appropriate. It assembles the out-of-order packet when they reach the destination. It handles the error transmission packet and the fragmentation of data packet. Some of the protocol used is the IP protocol, which connection and unreliable protocol. And the protocol will provide the best available transport packet. We talk about this one. Address resolution protocol (ARP) is a protocol map the logical address or the internet address of the host is physical address printed in the network interface card. MAC address. Reverse Address Resolution Protocol (RARP) is finding the internet. Its job is to find the internet address of a host. Its physical address is known. Internet Message Protocol (ICMP) is monitors the queries as well. Error message used for error and diagnostic function. This will interact with the application layer. Uh, Internet Group Message Protocol (IGMP) allow the transmission of a message to a group recipient simultaneously, like a multicast. Finally, the layer 1 network access layer, or some people say link layer. This is the first or the lowest layer of the TCP model. It is job is to define details of how data is physically sent to the network, including how bytes are electrically or optically sent in or encoded by hardware device that interface directly with the network medium, such as fiber, uh, straight cross connect, copper, or just coaxial cable. The protocol in this layer provide the means for the system to deliver data to the other devices on a direct attached network. It defines how the network transmit over an IP datagram. Unlike high-level protocol, network layer must know where to define underlying network, uh, if it is packet or addressing structure, etc., and to be able to correctly format the data and to transfer it to the network constraint. It also encompasses the function of all the three lower layers of OSI reference, that being network data link, and physical. It accepts IP packet from the layer, from the network layer, and encapsulate them into frames. Frames here. You can see we have header and also tail or trail, um, to make them into frames. Uh, it's it synchro it synchronizes the transmission of the frame as well as the bit, making up the frame between the sender and receiver. It states the transmission mode, i.e. simplex, um, fullplex, or half duplex. Um, this is very now people use full duplex most of the time. It states the topology of the network, pass ring, pass star ring, etc. This is also very old. People use switch these days. Um, it's also called a network interface layer or link layer. So, also the combination consider as combination of physical layer and data link layer of the OSI model. The protocol in this layer support Internet Frame Relay, Token Ring, ATM, asynchronous transfer mode. The core protocol specified by the Internet Engineering Passport (IETF), IETF. In this layer are Address Resolution Protocol (ARP), the Reverse Address Resolution Protocol (RARP), the Neighbor Discovery Protocol (NDP). However, the most popular non-structured ar- architecture among those listed above are Internet or IE 802.3. Internet uses an access method called ACMP at CSMA-CD, which stands for Carrier Sense Multiple Access Collision Detection. To access the media, when the Internet operates in a shared media, an access method determines how a host will be placed upon on the medium. In the CSMA-DC access method, every host has equal access to the medium and can place data on the wire when the wire is free from the network transmission. The network traffic. When a host wants to place data on the wire, it will check if the wire already occupied by other hosts, um, and if there is already, it will wait and if there is not, it will take and place the data in the middle. However, if both of those systems place the media at the same time, this will cause them to collide with each other and destroy the data. If the data is destroyed during transmission, they will need to be retransmitted. Uh, so each host will wait for a small random time amount of time and resend again the data. Okay, now we're going to talk about encapsulation process. Encapsulation process mean um, the lower layer of TCP/IP protocol will wrap or pen encapsulation of the upper layer data with header and add its own header or footer with protocol information. Um, for example, right here, you can see data and being wrapped with transport header here. This the data encapsulation is yeah. So basically, data encapsulation has minimum of a header with the sending and the receiving host address and a body with data to be transferred. So basically, we have the data, which is the body. We have the header, and we have each layer with will add its own header or layer. If you can see right here, frame we have its own uh, frame tailor or railer, trailer or tail. Aspect. Okay. Um, so basically, at each protocol, either add or remove um, field from the basic header and the protocol on the sending host add to its packet. The process is called data encapsulation, and each layer has its own different term for all the packets. For example, this one for the transport layer, we will call it segment. For the internet layer, we will call it packet. For the network access, we will call it frames or bits, frame of bit. We have an example here. In the IP suite, the content of the web browser are encapsulated with HTTP header and HTTP for messaging and the IP header and finally a frame header into the responsible respective protocol data units and interpret at each layer by the receiving nodes. This is decapsulation process. The result of encapsulation at each lower layer provide a service for the layer above it. At the same time, each layer communicates with its corresponding layer on the receiving node. They are known as adjacent layer interaction or same layer interaction respectively. So let's go down for the encapsulation. For decapsulation, we go up. So when a layer send a message or a command to the application protocol associated with transport the message form that it can be handled by the appropriate transport protocol TCP or UDP. Suppose the user issue a logging command. The command will use TCP transport layer protocol, and TCP expect to receive data in stream of bytes containing the information in the command. Therefore, outlogging send this data as a TCP stream. No application layer protocol use TCP. A user can also mount a file system with remote host, thus inserting NIS plus application layer protocol. This NIS use a UDP transport layer protocol. Therefore, this packet contains command that must be formatted in the manner that UDP expect. This type of packet is referred to as message. So, this process begin at the transport layer. At the transport layer, the end result on whether the TCP or UDP has ended the information. TCP is often called connection-oriented protocol because it ensures the successful delivery of data to the receiving host. TCP show that TCP divide the data into segments. So the data is split into segments and it will attach a header to it. The segment header will contain the sender and the receiving port. Segment order the information and the data known as checksum and data field known as checksum. The TCP protocol on both hosts use the checksum data to determine whether the data received have been transferred without error or not. Establishing TCP connection, TCP use segment to determine whether the receiving host is ready to receive the data. When sending the TCP want to establish connection, it will send a segment called SYN to the peers connection to peers TCP protocol running in the receiving port. The receiving TCP return a segment called ACK to acknowledge that successful recipient segment. After this, they will send the TCP. The TCP will send another ACK segment and proceed to send the data. This exchange for control information is referred to as three-way handshaker. As a term, UDP packet is a connectionless protocol, so this is probably for wireless. Unlike TCP, it does not check to make sure the data arrives at the receiving host. Instead, UDP just take the message received from the application and format it into UDP packets. UDP attach a header at each packet with contain the sending and receiving host port, a field of a field with the length of the packet and a checksum. So another checksum here and here. The sending UDP process to and to send the packet to use UDP process to the receiving host. The application layer determines whether the receiving UDP packet acknowledge that the packet has been received. UDP require no notification of receipt. UDP do not use the three-way handshaker. Internet or network layer. Both ICP and UDP pass the segment and packet down to the internet layer, where they will be handled by the IP protocol. The IP prepare them to delivery by formatting them into a unit called IP datagram. IP then determine the IP address and IP address for the datagram so that they can deliver to the receiving host. IP attach the IP header. In here, it will be IP header and the segment or packet header in the addition to the information added to the TCP. Talking about this network header and network then the transport header. Information in the IP header called IP address of the sending and receiving host. They will also put in data lines, datagram sequence order, so that the in case the datagram exceed the allowed byte size for the network packet, then must be fragmented so that they will be able to reassemble it. And also frame trailer has hack or error checker, data link layer, framing take place, new layer. Um, so this one is a new TCP/IP model. Uh, I will talk about this. Uh, Data layers such as PDP or IP datagram into frame. They attach a third header called and a footer to the frame to the datagram. Here, field that check for error as the frame travel over the network media. Then the data link layer pass the frame to the physical layer. We send it. So the physical layer on the sending host receive the frame, we take it and convert the IP address into hardware address appropriate to the network media. This could be a switch or router. The physical network layer then send the frame out over the network media. The network access layer header and propeller only relevant for physical network. So wireless we probably don't use this. When a router receives a frame, it strips the header, trailer add a new header and trailer before sending it out in the next physical network toward the destination. And finally, the calculation process will take place. As a final example, for example, when you message a friend or using a program, chat program, the message will pass to that layer and to the transport layer. The transport layer will encapsulate the entire data, uh, the message, and add it to TCP header. Can be UDP data or only depend on the application, the protocol itself. After they will send it to the internet layer and add the IP header or footer. Then send it to the access layer. And the same process will happen again in the network access layer. Then encapsulated data is sent to the physical layer linked to the internet. And your friend will receive the data and then he will decapsulate in his programming. So when the encapsulation data the unwrapping decapsulation, it will remove the frame header. We remove these two, and then we go up, and then we will remove the network header, and we also remove the IP address, remove the transport layer, and we say happen until the original data that you sent will arrive to your friends, and your friend will be able to see the message you. Now I'm going to talk about protocol data unit or PDU on each layer. PDU is a single unit of information transmitted among various entities of a computer network. A PDU is comprised of a protocol-specific control information and user data. In the layer architecture of communication protocol stack, each layer implements protocol tailored to that specific type of data exchange. For example, transmission control protocol implement a connection-oriented transformer, and the PDU protocol of this protocol is called a segment, while the user protocol data use datagram. As protocol data unit, For connectionless communication, laying lower in the Internet's protocol suite as the Internet layer, the protocol, the PDU is called a packet, irrespective of the PDU type, segment, packet, frames, and bits or sim, yeah, give or takes. Um, Given context containing the specific OSI layer, PDU is also synonym to its specific representation of that layer. In the context of packet switching data network, a protocol data unit is best understood in relationship to a service data unit (SDU). The layer pass service data unit across the interface. The higher layer understands the structure of the data in SDU, but the lower that layer at the interface does not. So the lower layer treat the SDU as payload and therefore become a service data unit to the layer, and the layer merely delivers it. So what this means is that when the upper layer send in data or data header to the lower layer, the lower layer does not actually understand it, but it only processed it and then sent it to the lower layer so that the so that the so that the data will never go up unless this is for decapsulating data until it arrives at the bits. In order to do this, the protocol lower layer we add an SDU token data init for its function, which is called encapsulation. The addition of addressing and control information of SDU to form PDU and the placing of that PDU to the next lower layer as SDU repeat until the lowest layer is switched for some medium as a physical signal. So they will repeat this until they found a medium to transfer it for. So for example, it might add a port number to identify the application, network address to help routing, spot the IP address maybe, code to identify types of data in the purpose, and error checking information. All this additional information plus the original data you need from the higher level constitute the protocol data unit at this layer. PDU is the structured information that is passed to a matching protocol layer onto further along the data journey that allow the layer to deliver to the extended functional service. The matching layer or peer decode the data to exact the original service data unit, divide if it is error-free, decide if it's error-free, and where to send its next, etc. And as we already arrived at the lowest one, PDU is passed to the peers using services to the next lower layer protocol called stack. When the PDU one of these layers send a SDU to the layer lower one unit, then it plus many metadata, either or trailer, layer, and negative one adds to the SDU with exceed the largest size layer and and dash one as PDU can is 1500 octet. IP fragmentation will be invoked so that it will chop it up. Yeah, not chop it. We will divide it into multiple payloads so that you fit the layer and PDU size standard. I believe that is all. Thank you very much for listening. Goodbye.